Welcome to the Explainer. Today, we're going to transform your slow, oversized Docker images into some seriously lean, mean, production-ready machines. Let's get right into it.
Let's just start with a number, a big one, 90%. Yeah, that's how much you can potentially shrink your Docker images just by using the right techniques. We are talking about going from gigabytes all the way down to megabytes. That means faster deployments, lower costs, and honestly a much happier you.
So, are you tired of just staring at build logs, dealing with those long waits, paying for image registries that are just completely bloated? If that sounds familiar, you are definitely in the right place. So let's roll up our sleeves and really tackle this thing head on.
Okay, first up, we're going to dissect a super common but incredibly inefficient Docker file. Let's call this our problem child, because it's the perfect example of what not to do. This right here, this is where all the bloat begins.
This probably looks pretty familiar, right? You copy the entire project directory first, and then you go and install all the dependencies. It seems innocent enough, but this one little mistake leads to absolutely huge images and painfully slow rebuilds every single time you change just one line of code. But why? Why is it so bad? Well, the secret is all in the layers. To fix our file and really truly optimize our builds, we first need to get our heads around the fundamental building block of every Docker image, layers.
Okay, so don't think of a Docker image as one big single file. Instead, picture a stack of transparent sheets, like from an old overhead projector. Each instruction, like run, copy, or add, adds a brand new sheet, a new layer, with a specific set of changes. Everything else is basically just metadata, like a little label on the side of the stack.
And this slide right here, it perfectly illustrates that stack in action. You start with a base OS at the bottom, then you add your language runtime on top of that. Next, you install all your dependencies in another layer, and finally, right at the very top, you add your own source code. See? Each step builds on the last, creating this whole history of your image.
So, here it is, the most crucial point, the one golden rule of Docker caching you have to remember. If you make a change that affects one layer, every single layer built after it has to be completely rebuilt from scratch. It doesn't matter if those later steps haven't changed at all. This is the key to absolutely everything.
Okay, now that we know the theory, let's apply this new knowledge about layer caching to our Docker file and score some really big, immediate wins.
The single biggest mistake people make is copying their entire source code before installing dependencies. That's the wrong way you see on the left. And why is it so wrong? Well, because every time you change a single line of your application code, Docker has to throw away that layer and then rebuild the entire slow dependency layer that comes after it, every single time. But by just reordering, copying only the requirements.txt file first, installing your dependencies, and then copying your code, we create this stable dependency layer that almost never needs to be rebuilt.
Here's another incredibly easy win. Combine your run commands. Remember, every run instruction creates a whole new layer. By chaining related commands together with an and, you smash them all down into a single, much more efficient layer. This also means you're cleaning up temporary files, like package manager caches, in the same layer where you created them, which stops them from bloating your final image. It's a 2-for-1.
And the impact is immediate. You can see it right here on this chart. Instead of 3 separate layers for what's really just one logical operation, installing a package, you've got just one. Simple as that. It makes your build history cleaner, and it makes your final image smaller.
Okay, we've covered the basics and made some great progress. But now it's time for the real game changer, the technique that delivers that massive 90% size reduction we talked about at the beginning. I'm talking about the powerful multi-stage build.
The core idea behind multi-stage builds is actually brilliantly simple. You just use one container as a sort of workshop to build your application, and then use a second totally clean container for the final product. No extra tools, no junk, just your application ready to go.
So first, we define a builder stage. We give it a name, you can see it right there, AS Builder. This is our workshop. It's a big, full-featured image where we install all our heavy development dependencies, our compilers, and any other tools we need to actually build our application.
Then, in the very same Docker file, we start completely fresh. A new, tiny production image, something like Alpine. And here it is, the magic command. Copy. Dash from Builder. This little line lets us reach back into our first builder stage and pull out only the compiled files we need, leaving all those heavy build tools and dependencies behind forever. It's like magic.
And the result? Well, it's nothing short of dramatic. Look at that.
By separating the build from the final artifact, we've gone from a bloated 1 GB image packed with unnecessary stuff down to a lean, secure 100 MB image that's ready for production. And it's not just smaller and faster, it's way more secure because you're not shipping your build tools out into the world.
That is a 90% reduction in size. I mean, think about it. This makes your deployments faster, your CI/CD pipelines quicker, and your storage costs way, way lower. If there is one major technique you take away from this explainer, it has to be multi-stage builds. So go try it out.
So how can you start applying all of this right now? Don't you worry, I've got you covered. Here is your actionable checklist for writing professional, efficient Docker files every single time. All right, just follow these key steps. Always optimize for the build cache by ordering your instructions from least to most frequently changed. Reduce your layer count by combining those run commands. Use multi-stage builds for, well, pretty much everything. Start with the smallest space image you can get away with, and please, use a Docker ignore file. Master these and you'll be a Docker pro in no time.
Look, the best way to learn is by doing. So pick just one of these techniques, maybe reordering your copy commands or trying your first multi-stage build, and apply it to one of your projects today. You are going to be amazed at the difference it makes. Thanks so much for joining this explainer. Now go forth and build smaller, faster Docker images.